Okay, good morning all. Start ചെയ്യാം. Audible ആണോ? Screen visible ആണോ? Any issues? Reply ചെയ്ത chat window ല്. Okay ആണല്ലേ? Screen visible ആണ്. Audio okay ആണല്ലേ? Right. So let us start. Right. Okay. Last class we brought our Zener diode into the circuit, and you can expect few questions, theory questions based on the operation of a Zener diode. First one is, the Zener diode operates as a voltage regulator, or it acts as an ideal voltage source when it is reverse biased, and it should be in reverse breakdown mode. Right? Reverse breakdown mode. And second one is, Zener breakdown occurs due to the mechanism called Zener breakdown mechanism or Zener effect, and that is predominant in the lower voltage regions. Compared to avalanche breakdown, Zener breakdown occurs in the range of lower voltages compared to your avalanche breakdown. Third one is, once the Zener diode is breaks down, that can be used it again. It's a reusable diode even after the reverse breakdown. Whereas our normal diode will damage after a reverse breakdown. And once it is in breakdown mode, the potential at cathode here is more positive than anode, or it acts as a voltage source between its cathode and anode, not in between anode to cathode. And the reverse current ideally can be any value, and that reverse current flows in the reverse direction. Current can be any value. Voltage across the device will be Vz, implies act as an ideal voltage source. Okay, audio എന്തെങ്കിലും issues ഉണ്ടോ? Audio break ആവുന്നുണ്ടോ? കേൾക്കാൻ ബുദ്ധിമുട്ടുണ്ടോ? ബ്രേക്ക് ആവുന്നുണ്ടോ ഇടയ്ക്ക്? ഓക്കെ ആണല്ലോ അല്ലെ? ഇടയ്ക്ക് ചില പ്രശ്നങ്ങൾ വന്നേക്കാം. എന്നാൽ അത് കണ്ടിന്യൂസ് ആയിട്ട് ഒരു 30 സെക്കൻഡ് അധികം ഉണ്ടെങ്കിൽ നിങ്ങൾ ഹൈലൈറ്റ് ചെയ്യുക കേട്ടോ. ചാറ്റ് വിൻഡോയിലോ അൺമ്യൂട്ട് ചെയ്തിട്ടോ പറയാം. റൈറ്റ്. ഓക്കെ, താങ്ക് യു. So these are the 1 mark or 1 word questions based on theory portions of your Zener and avalanche breakdown. Avalanche breakdown involves collision between atoms. The highly accelerated electrons will collide on atoms that will generate multiple electrons. All those electrons will again accelerate the high electric field that will again collide with atoms, and multiple times of collisions will increase the number of carriers that will increase the reverse current. Finally, high velocity carriers collide with atomic structure, then atomic structure also get disrupted, so diode loses its electrical properties. Right. Okay, today we are planning a few more numerical problems based on our Clipper circuit. Right. So let us get into first problem based on the Zener diode. Suppose you have 2 Zener diodes connected. This circuit we had discussed yesterday. Let us make it as 2 Zener diodes connected like this. Like this. Between 2 equal resistors. Let us mark it as 10K and 10K, right? And my input is a non-input signal, that is a square pulse operating between, let us say, a plus 10 volts to minus 10 volts. Minus 10 volts. Right? So you are asked to identify or plot the output waveform with respect to time. Right? So while attending the problem, you should understand that you should know about the breakdown voltages of Zener diodes. Let us mark it as diode 1, VZ1, let us say 3 volts, VZ2, let us say 5 volts, and this is your D2, this is your D1. And both the Zener diodes are ideal, implies forward biased mode, it acts as a short circuit, current is very high. Reverse before breakdown, reverse current is ideally 0. Once it crosses the breakdown point here, VZ1 or VZ2, the reverse current increases sharply and the voltage across the diode will be VZ with the cathode positive, anode negative, VZ. Right? So input signal has two levels only here, either plus 10 or minus 10. So your transfer characteristics will be having 2 points, one point corresponding to Vin equal to plus 10, another point corresponding to Vin equal to minus 10. So there is no point in drawing transfer characteristics, and we have to plot the output waveform. And as we discussed yesterday, addition or subtraction of a DC signal with the input waveform will not change the shape of the waveform. Right? Voltage level will change. So we are expecting this kind of waveform. Let us see that, how it will be. This is V out. So when input is at plus 10 volts, you can replace your input with a plus 10 volt source. And of course, positive input reverse biases your Zener diode T1, and its breakdown voltage is 3 volts in the reverse direction, but we have a reverse voltage of 10 volts. So that breaks down. The moment that breaks down, cathode is positive with respect to anode with a voltage of VZ, that's equal to 3 volts. Then your D2 diode, anode is connected. If you're subtracting 3 volts from 10 volts, we'll still get a positive value. So this will be a positive value at anode. So D2 will not remain as open. It is forward biased. It acts as a short circuit. And we have 10K resistance in series as well as across, without 10K and 10K. So you have to identify V out, that's it. So while identifying V out, this is negative, positive 3, positive, negative 10. Effectively, the voltage source will become 10 minus 3. That is nothing but 7 volts. 7 volts. And 7 volts divides equally between 10K resistors. So we'll get a 3.5 volts positive. So this amplitude will be positive 3.5 volts. Right? The other case, when output is at minus 10, sorry, input is at minus 10, input has only two values, plus or minus 10. When it is minus 10, you can replace the source with a negative positive 10 volts because it is at minus 10. and your D1 is forward biased, act as a short circuit, right? Whereas your D2 will be reverse biased because it is a short circuit and you're having a negative voltage at the node of D2. D2 is reverse biased, and that reverse voltage is greater than the required breakdown voltage of the diode. So it breaks down. Once it is in breakdown, you can replace it with a voltage source with a cathode positive, anode negative. Vz is nothing but 5 volts. 5 volts. Again, plus minus 5, negative positive 10. Effectively, the voltage source will be minus 5 because minus 10 is dominating here. So this will become 5. Polarity negative and positive. And 5 divides equally, minus 5 divides equally implies your output will be minus 5 volts in this polarity. So this lower level will be, sorry, not minus 5 volt, minus 5 divides equally between the resistors, sorry. So minus 5 by 2, that's equal to minus 2.5 volts. So this is nothing but minus 2.5 volts. So if you are giving a square wave with amplitudes plus or minus 10, the circuit removes all those amplitude greater than 3.5 and all those negative amplitudes less than minus 2.5, right? Minus 2.5 and positive 3.5. Right? So if you want to remove some portion of your input waveform, or if you are sure that your input will have a noise component above 3.5 and below minus 2.5, if you want to remove that noise component, addition of noise, you can easily clip it off by using a series clipper with certain diodes connected back to back. Right? Of course, the transfer cards will have only 2 points. At plus 10, you will have 3.5 volts out. At plus 10, you will have 3.5 volts here. And minus 10, you will have minus 2.5 volts. 2 points. Okay. And with respect to the average value of input signal, what is the average value of the input signal? It's a symmetrical square wave with equal positive and negative amplitudes. So average value will be area of positive portion minus area of the negative portion. They are equal. So average value will be 0 volts for the input. If you are marking it as T, for T by 2 period it is plus 10, another T by 2 period it is minus 10. So taking the area, one is positive, another is negative, equal, cancels each other, average value will be equal to 0. Whereas if you are looking into the output signal, they are not symmetrical. The average value not equal to 0. So while calculating average value of the output signal is nothing but 1 over total period. This is my total period. Integral over the period V out dt. Right? So here 1 over period you can split into 2. So up to T by 2, half of the time period, output is 3.5. So I'm integrating from 0 to 0 to T by 2. T by 2. That is nothing but 3.5 dt constant. And 1 over T is common plus another interval T by 2 to T. You will have minus of 2.5 dt. So integrating this, one is positive, another one is negative. So average value will be equal to 1 by T is common. So 3.5 into T by 2 minus 0. So 3.5 times T upon 2. Then minus 2.5 T. 2.5 T by 2. T minus T by 2 will be T by 2 itself. So 2.5 into T by 2. Negative. And this T will cancel each other. So average value will be 1.5. 3.5 minus 2.5 is equal to 1. So 1 upon 2. That will give you 0.5. It is obvious that positive portion is larger in the output waveform. So in the examination, you may ask to identify maximum and minimum values of output voltage, that is plus 3 and minus 2.5. Average value of the output signal for a given input signal, that is nothing but 0.5. And you may ask to identify the transfer characteristics. Transfer characteristics will have only 2 points because input is having only 2 values, plus 10 or minus 10. And if you are placing your resistor, 10K resistor, here in front of the diode, if you are placing 10K here, then your normal circuit, the expected output is same. You can place 10K either here or here. Doesn't matter, right? So moving this resistor to here will not change the response of the circuit because this is in series with input and output, irrespective of the position here or the other point here, right? Okay. So let us have another problem, another simple problem that you can easily answer. You are asked to identify the current flowing through the ideal diode. This is 1 milliampere current source shunted by a 2 kilo ohm resistance, and diode is placed here. The other side of the circuit, you have 1K resistance connected like this, and you have 1 milliampere current source there. You are asked to identify the value of current I flowing through the diode in the given direction. What will be the value of current? To identify the value of current, you should know the status of the diode, and diode is ideal. If it is open, no doubt, current will be equal to 0 amperes. If it is in closed position, closed switch, I not equal to 0 amperes, right? To identify the status of the diode, our conventional procedure is nothing but to open the diode, identify the anode voltage, identify the cathode voltage. If V anode is greater than V cathode, diode is forward biased. When it is forward biased, you can replace it with a short circuit, right? So, if you are opening the path, the other path, and there 1 milliampere flows through 2K, drop will be 2K into 1 milliampere, 2 volts. Here it is 2 volts with respect to ground. This is reference ground. And V cathode, the entire 1 milliampere flows through 1K, generate 1 volts drop. Vk will be 1 volts. And of course, V anode is greater than V cathode. So the diode cannot stay in open circuit mode. Of course, it will turn on and act as a short circuit. Or the other way, you can convert this current source in parallel with the resistance with an equal voltage source, 1 multiplied by 2, 2 volts, in series with the same resistor here, 2K. And you have diode connected here. Similarly, the other circuit, 1K into 1 volt, in series with 1K resistance, using the source transformation, 1 volts. It is clear that this potential is larger than this, so diode turns on, act as a short circuit, and the current flowing through the diode I will be nothing but, as per Ohm's law, these two are in series, potential difference is 2 minus 1, so I is nothing but 2 minus 1 upon total resistors, 3 kilo ohm, will give you 1 by 3 milliamps, right? 1 by 3 milliamperes. And if you are keeping the circuit as such, you have to apply nodal analysis here. This node voltage will be V. This node voltage also will be same voltage V because they are shorted. So you can assume this node voltage as V. Then 1 milliampere is coming up. V minus 0 by 2. V by 2 milliampere is going down. And there is a current I going towards right, and there is a current V by 1, that is V milliampere going down, and 1 milliampere current coming to node. So if you are applying Kirchhoff current law at that node, you can solve the unknown current I, and that will be again equal to 1 by 3 milliamps. And this will be quite simple than the other method. So diode is forward biased and current flowing through the diode is nothing but 1 by 3 milliamperes. Right? Clear? So let us see another circuit that also involves current source. These are quite simple even though we are having a current source. You need not worry about the current source and number of diodes in the circuit. Apply the standard procedure, then identify the circuit parameters. In this circuit, this is 4 kilo ohm, this is 2 kilo ohm, this is 1 milliampere current source. This is my diode D1, this is my diode D2. You are asked to identify, you have to find I1 and I2. I1 is the current flowing through diode D2 and I2 is the current flowing through 2 kilo ohm resistor. And both diodes D1 and D2 are given as ideal. We don't know the status of the diode. Of course, D2 will be reverse biased and I1 will be 0. That can be directly returned from the circuit. Right. Anyway, let us open circuit. Open those diodes. Once it is open, enter 1 milliampere flows through this. So 4 plus 2, 6. They are in series. So this voltage with respect to reference node ground here is nothing but 4 plus 2, 6 into 1 milli, 6 volts. And this voltage with respect to ground is nothing but 1 milliamp into 2 volts. Or this voltage drop is 4 volts. And my diode was connected like this. Of course, its anode is positive than cathode, so you cannot open your diode. It will be operating in on state short circuit. Whereas your diode D2 was connected like this. Its anode is at 0 volts and its cathode will be at positive voltage. So D2 will be reverse biased. So it acts as an open circuit. So I1 is nothing but the current flowing through the diode D2. Its reverse bias 0 amperes. Anyway, the current was marked from cathode to anode. So ideal diode, that current should be equal to 0 if the diode is reverse biased. And to identify I2 current flowing through 2 kilo ohm, under this condition, D2 is open and D1 is short circuited because it is in on state. So since diode is shorted, the potential difference across 4 kilo ohm resistance is now 0 volts. 0 volts because it's either ends are shorted together, 0 volts. Implies no current flow through 4 kilo ohm resistor. Or the other way, the current source is observing two parallel branches. One is perfect short, another one is with a 4 kilo ohm resistor. So entire 1 milliampere current will flow through the short circuit milliampere. And that 1 milliampere comes here, this direction. And that 1 milliampere flows through diode, and that 1 milliampere flows into the current source. So I2 in this example is nothing but the current source value that's equal to 1 milliampere. That's it. Any doubts? So the problems was quite simple. Right. Let us get into another problem that is a common problem asked in competitive examinations that has 3 diodes connected like this. 3 diodes. Reference voltage is the same. All cathodes connected together and inserted a resistance here. This is the out. This is R. Let us assume this is 3 volts. This is 2 volts. This is a 1 volt. You are asked to identify the out. How much is the out? You have 3 diodes. Let me mark it as D1, D2, D3. The circuit contains 3 diodes. Each diode will have 2 different possibilities, either on or off. So there are 2 raised to 3, 8 different states of the circuit. In our last problem, there was 2 diodes. In this case, 2 diodes. 2 power 2, 4 combinations were there, 4 different states of the circuit. And one state, let me write it as, let me mark it as D1 and D2. Both are off. Both are off. And in this circuit, that is not a valid state because D1 anyway turns on, right? And the other state is both are on. That is also not true. D2 will turns off. The other state was D1 on, D2 off, and that is matching with the circuit conditions, and that was actual state of the circuit. And the other case was D1 off, D2 on. That is also not possible. Actually, we have to draw 4 different circuits for the given problem, analyze each circuit, then we will understand that both never stays at off mode, both never stays at on mode. D1, if D1 is off, D2 never becomes on. So the only possibility is D1 on, D2 off, and that was our solution. Similarly, here you will have 8 different cases, and analyzing all these 8 cases is meaningless. Right? Among the 8 cases, one case will be stable and output will be equal to a particular value corresponding to that valid state of these 3 diodes. So let us assume this. Let us assume that V out can take either 3 volts, 2 volts, or 1 volt. No other choices. Let us assume output is 1 volt. If this is 1 volts, D2 turns on, shorted. D3 also turns on, shorted. Once D2 is shorted, output demands plus 2 volts. When D3 is shorted, output demands plus 3 volts. So you are actually paralleling 2 different voltage sources. That is not possible. That violates Kirchhoff voltage law. Or the other way, if you are fixing output as 2 volts, cathode of D3 is at 2 volts, but its anode is at 3 volts. So it will turn on. Once it is in on state, it acts as a short circuit and output demands a 3 volts. If you are marking output as plus 1 volts by turning on diode D1, shorted, then D2 also turns on, output demands 2 volts. D3 also turns on, output demands 3 volts. That is not a stable state. So the only stable state is D1, D2 remains in off state. D1 and D2 remains in off state. And D3 turns on. And this output becomes V out is equal to 3 volts. 3 volts. 3 volts. When output is 3 volts, never D1 and D2 turns on. So it's a stable condition of the circuit. So highest voltage will turn on the respective diode and V out is clamped to 3 volts. That ensures turning off D1 and D2 diodes. So in this case, output will be plus 3 volts. Clear? Any doubts?
So can you explain again?
Yes. There was 3 diodes and 3 voltage sources. Right? So turning on of the diode can be either for D1, D2 or D3. Right? So if you're assuming that D1 turns on, so it is shorted. So your output node will be equal to, this is shorted, so this will be at plus 1 volts. Here also plus 1 volts, plus 1 volts. That will turn on D2 as well as D3. The moment D2 turns on, act as a short circuit. So it demands a plus 2 volts that actually contradict with the initial output.
Okay.
And if this is 2 volts, this diode never will turn on because its anode has only 1 volt. So if this output is 2 volts or this is on state, you should open it. This will be definitely in the open circuit mode or reverse biased.
Same.
Again, if this is 2 volts, your D3 diode will turn on. So that demands a 3 volts here. The output side, that will effectively turn off diode. So the stable state of the circuit will be Vout equal to 3, in which D1, D2 will be in off state and D3 will be in on state.
Understood.
Out of 8 possible states, only one valid state, D1, D2 off, D3 on. Right? Okay. Any other doubts? Let us get into the other problem in which we have a resistor connected in series with my diode. That kind of problems we didn't discuss in yesterday's class. So let us have another circuit. Input is as usual 10 sine omega t. You have a 10K resistance in series with the input source. You have two branches. One diode is connected towards up with a reverse bias of 4 volts. And there exists another 10K resistance here. Right? Whereas in the other branch, that is quite simple, your diode is connected the other way. And it's also reverse biased with a 4 volt source. And these are your output terminals. The question is very simple. Identify the maximum and minimum values of Vout. We have options +4, -7, -4, +7, +10, -10, +7, and -4. Input is 10 sin omega t. Diodes are ideal. You are asked to identify the maximum and minimum values of Vout. So we have one extra 10K here. No other changes. Right. The second branch, any answers? Okay, right. Our normal procedure is opening the diodes. So I'm opening this diode, right? So two branches are open, no current flows through this branch, no current to the output side, it's open. So no drop across 10K resistor. So V out is nothing but V in, right? So as I said, the basics of this is actually the transfer characteristics. Using transfer characteristics, you can answer all the questions related to your Clipper circuit. This is V in, this is V out. So when both diodes are on, V out equal to V in, and V in will appear here. That V in is appearing at the anode of your second diode, D2, and cathode of first diode, let us say D1. Input can have two possibilities in broad sense, either positive or negative. Both diodes are reverse biased with a 4-volt source. Why it is reverse biased? And cathode is connected to positive 4 here. Anode is connected to minus 4 here. So both are reverse biased. So if Vin is positive, D1 is already reverse biased. This voltage is positive. Vin implies cathode is positive. So during the positive input interval, D1 never turns on. Is that clear? D1 is already reverse biased with anode voltage of minus 4 volts. During the positive portion of your input signal, your cathode is having positive. A positive signal at cathode will never forward bias the diode. It will forward bias if and only if your anode is more positive than your cathode. But unfortunately, your anode is at minus 4 volts with respect to ground when it is in open state. So in your positive cycle or positive portion of the input, your diode D1 never turns off. So it never turns on. The only possibility to turn on the diode D1 is to make your input voltage negative, and that to less than how much volts? Minus 4 here. So this should be less than, Vin should be, or V cathode should be less than minus 4 volts. So if Vin exceeds minus 4 in the negative direction, then there is a possibility that D1 turns on. No other possibilities. So from minus 4 to 10 volts, in our case, minus 4 to 10 volts, in this interval, you can see that diode T1 is in open state. That's clear. So if Vin is greater than minus 4 and less than 10, because we are limited by some volts, D1 is in open. D1 is in off state. That is clear. Right? Let us concentrate on diode D2. Again, if diode D1 and D2 are in open state, we are opening both diodes initially to identify the range of voltages at which they will turn on. So if D2 is in off state initially, your Vin was present here, that is 10 sin omega t. If that Vin crosses 4 volts, Vin crosses 4 volts, your D2 turns on. So the moment your Vin crosses positive 4 volts, your D2 turns on. And of course, as we discussed, D1 will be in off state. Right? And if Vin is less than 4 volts, in this region, less than 4 volts, or minus 10 to plus 4, minus 10 to plus 4, your D2 will be in off state. D2 will be in off state. So here we are having overlapping regions. In this region here, Both D1 and D2 are off. D1 comma D2 are off. Whereas in this region here D2 off, D1 on. Off, D1 on. Right? And also here in this region, your D1 is open and up to V equal to 4 volts, your D2 is also in off state. So D1 off, D2 off is common from -4 to +4, in which both diodes are in off state. Clear? Any doubts? The question can be either identify the range of input voltages in which both diodes are off state, in off state, both diodes are in on state, D1 on, D2 off, D1 off, D2 on. And we have three regions, I think here. One is D1 off, D2 on. Second is both are off. Third region is D1 off, D2 on. And we don't have a state in which both diodes are in on state. So out of four possible states, the circuit says from third state to second state to first state if you're varying input from -10 to +10. Is it clear? Any doubts? Detailed explanation is not at all required to identify the output voltage maximum and minimum value. Quickly you can do that. But to understand the circuit properly, I'm explaining based on the transfer characteristics. During the examination, you need not draw these transfer characteristics. Directly, you can go for an output voltage maximum value plus 4 volts. And of course, that will be -7. That will see that. What will be the answer? So to answer all other questions based on the range of input voltage at which both are on, both are off, D1 on, D2 off, or which of the following state is a not valid state if you're varying your input from -10 to +10. Both on state is not a valid state. And if your input is 4 sine omega t, then you have only one valid state, that is both are off, right? That's off. So the operating region of the diodes depends on input signal. If you're applying only 4 volts, maximum value at the input side, -4 volts, minimum value at the input side, your circuit never goes to these two regions, D2 off, D1 on, D1 off, D2 on, and it will stay always in both are off conditions, right? Okay. So if both are off, what will be the output? Both are off implies this is open, this is also open, and you have a connection like this, both are open. No drop across 10K because no current through the branches. So V out equal to V in. So in your second region, V out is equal to V in. This is my second region. -4 to +4. I will draw it here. I will draw it in the next slide. So from -4 to +4, that was my second region, in which both diodes are open circuit and V out equal to V in, because there is no drop across the resistor. V out is same as V in itself. So the curve will be a linear curve passing through the origin. This was my V out, X was my V in. So it will go up to 4, up to -4. So this will be -4, this will be +4. V out equal to V in. And let us concentrate on first region, that is D1 of D2 on. D1 of D2 on implies this branch is open and this diode D2 is short circuit. The moment D2 is short circuit, it is clear that, obvious that output voltage is nothing but 4 volts. So if your input goes beyond positive 4 volt up to 10, the diode D2 remains in on state, so output remains in +4 volts. Continuous. We are limiting at 10. If you are going beyond that, then also diode D2 will be in on state. And the moment you identified this curve, you can see that in the positive side, maximum possible voltage is nothing but only 4 volts. 4 volts. Let us concentrate on the third region here. This was my first region, this was second region, and the third region was here, D2 of, this was my third region, D2 of D1 on. D2 of D1 on implies D2 remains in open mode when circuited. D1 turns on. Then our circuit will become like this. We will have V in, then 10K resistor in series with this, then one branch, that branch has D1 short circuited -4 volts, negative positive 4, another 10 kilovolt. So negative positive 4, 10. And the other branch was open. So this is your output voltage. Right, this was 10K, this was 4 volts, this was also 10K. If you are in region 3, D2 of D1 on, D2 of D1 on here, D2 of D1 on here, D1 off, D2 was on here, both D1 comma D2 are in off state. Right, this is a simple circuit that has two resistance and a source V in along with the DC 4 volt source. Of course, output will be proportional to the input. Directly you can write it because you are having two equal resistors, right? Two equal resistors was there, 10K and 10K. So you can directly write it as equal resistors. V in divides equally, -4 divides equally. So V in -4 by 2. Or those who are not able to visualize that, you can go for a node analysis. I'm taking all the leaving currents, right? I'm summing to 0. So first leaving current I1 here is nothing but V out minus V in, V out minus V in upon 10K, plus the other leaving current I2 is nothing but V out. And you can see that this is a negative pole. So V out minus that potential, that is -4, divided by 10K, plus the third branch current is 0. So sum should be equal to 0. All the leaving current should be summed to 0. Implies V out minus V in plus V out plus 4 equals 0. Implies 2V out is equal to V in minus 4, or V out is nothing but V in minus 4 divided by 2. So in this region, third region, my output is proportional to my input. That's equal to V in by 2 minus 4 by 2 is nothing but minus 2. So this is of the form y equal to mx plus c. And your y-intercept is nothing but minus 2. Minus 2. Slope is 1 by 2. Here slope was 1 because V out was equal to V in. Now slope becomes flat slope is 1 by 2. And that y-intercept is at minus 2. Right? So least value of the output will be corresponding to least value of the input, that is minus 10. When V in is minus 10. So that is minus 10 by 2 minus 2, that is minus 5 minus 2, that is nothing but minus 7. Or you can easily identify that value by observing the circuit here. V in is negative, its least value is minus 10. Minus 10 divides equally between the resistors. So minus 5 contribution due to minus 10 plus negative poles are connected at the top of your V out node. So 4 divides equally, but output will be negative because negative pole is on top. So minus 4 by 2 will give you minus 7. You need not write, switch off and loaded. So maximum value is equal to 4 volts, it's obvious, and minimum value depends on V in. Maximum value never depends on V in once V in crosses 4 volts. So up to 4 volts, V out is nothing but V in. When it crosses 4 volts, V out maximum value is clipped at 4 volts. Right? All the voltages above 4 volts are clipped off. So V out is remains always plus 4 volt when it is in operating in first state, that is driven off T2 on. Right? That was the answer was first option A, and that you can easily identify. And the circuit will not change its response if I am placing a resistor here and a diode here and a minus 4 here, 10K. So you can place that 10K resistor in the earlier circuit anywhere in this branch. This analysis will be same. You can put this here or between diode and voltage source. Doesn't matter. You can make it up, no problem. You can put in between 4 volt source and a diode like this, change. When you are opening your diode, this potential is nothing but a minus 4 because drop across 10K is 0 volts when the branch is open. So placing that 10K in series, anywhere in series with the branch will not change your analysis, will not change its on output response, will not change this analysis. You can place anywhere this. Okay. All right. So if I am adding one more 10K here, let us see what will be the change. You need not analyze it again. As I said, you can place that 10K anywhere in series with this. So I'm placing a top of my diode G2. This was 4 volts. What is the change expected? And the response will not change if both are in off state, no change. Right? When both are off, both branches are open. Then Vout equal to Vin, no change. When D2 is in off state, then also no change in the transfer characteristics. When D2, second branch is open, we'll have a V out based on this. So this curve won't change, it will be same, right? And initially, if D2 turns on, output was clamped or output is fixed by this voltage source, and that was equal to plus 4 volts. Now, that is not happening here. So I have a 10K resistance here. Diode is forward biased, acting as a short circuit. Then I have 4 volts here. I have 10K here in series. And here my D1 was off. D1 will be off. So I'm not taking care of this branch, taking care of only this branch. So V in 10K, diode is short, 4 volts, right? And this will be my circuit, 4 volts out. And this happens when V in is positive greater than 4 volts. Otherwise, this diode will be in open state. So that again simple. You have two resistors, V in 4 volts. So V in divides equally plus positive 4 volts divide equally between the resistors. Both are 10K. So my V out will be nothing but V in upon 2 plus 2, right? So this is of the form y equal to mx plus c. Y-intercept is positive 2. So I should have a y-intercept here plus 2. Slope of the curve is nothing but 1 over 2, right? So the curve is not flat. Slope of the curve is similar to here, 1 by 2. So the curve will look like this. Y-intercept is at minus 2 volts. Sorry, positive 2 volts. Slope is 1 over 2 by 2. Goes. The only change is that positive maximum will depends on now plus 10, depends on the input. Initially it was at 4 volts always. Now V in is 10, output will be maximum. To identify that value, it's quite simple. My V out was equal to V in by 2 plus 2. So V out is nothing but V in maximum is 10, 10 by 2, 5 plus 2. That will give you positive 7. So instead of 4, you should write positive 7 when you should write positive 7 here. If you're adding one resistance here, no other changes. So 3 different regions, both are off in this region, D2 off, D1 on, D1 off, D2 on, and these values are not changing. And the circuit have 1, 2 break points. Break points implies the value of V in at which V out changes in your clipper circuit. So V out was V in. The moment it crosses 4 volts, output changes to some other value. So 1 breakpoint here. Similarly, if you are decreasing the input, V out was equal to V in up to here. After this, output changes. So this is another breakpoint. So minus 4 and plus 4 are the break points of the circuit. Value of breakpoint. Right, clear or not doubts undo? So that is actually the fundamental analysis of your any kind of slipper. Clear ആണെങ്കിൽ നമുക്ക് അടുത്ത പ്രോജക്റ്റിലോട്ട് പെട്ടെന്ന് പോവാം. Okay ആണോ? Any issues? Any doubts? കൂടുതൽ എക്സ്പ്ലനേഷൻ എന്തെങ്കിലും ആവശ്യമുണ്ടോ? Any other problems? Clear ആണോ? Right. Okay. Clear ആണെങ്കിൽ clear ആണ്. Right. Okay. Right. Okay. Let us have another circuit that will have a feeling that it is very complicated. Let us see that. I have a bridge circuit like this. And my diode is connected from here to here in series with a resistor. And the bridge is biased using a current source. Its value is 1 milliampere. The resistance values are given 2 kilo ohm, 3 kilo ohm, 4 kilo ohm, and 6 kilo ohm. You are asked to find out the current flowing through the diode Ix, current flowing through 4K, Iy, current flowing through 6K, Iz. And the value of resistance connected in series with diode is nothing but 1 kilo ohms. One milliampere, 2 kilo ohm, 4 kilo ohm, 3 kilo ohm, 6 kilo ohm. Identify Ix, current flowing through the diode, Iy, current flowing through 4K, and Iz, current flowing through the 6K resistance. We don't know the status of the diode. Diode is given as ideal. So we will open it, right? Open it. So that branch is opened. We have 1 milliampere current here. And that current source observes two different branches. Right? So based on the current division rule, you can write this branch current in the open circuit condition. It is Iy. The other branch current is nothing but Iz when this branch is open. Right? So total resistance is here 6. Here it is 9. So if you have two branches in which 4 plus 2, 6K here, the other branch 3 plus 6, 9K here, connected with a current source, 1 milliampere, it divides based on the resistance. So this was my Iy, I said. Iy is nothing but based on the current division rule, total current 1 milliampere multiplied by the other branch resistance 9 kilo ohm upon 9 plus 6, 15 kilo ohm. My Iz will be the total current 1 milliampere multiplied by the other branch resistance is 4 plus 2, 6. K divided by sum is nothing but 15. That will give you 3 into 3 is 9, 5 into 3 is 15. So 3 by 5 milliampere here. 3 by 5 milliampere. 2 into 3 is 6. 5 into 3 is 15. So 2 by 5 milliampere. So that is nothing but 0.6 milliampere here and 0.4 milliamps here as expected. Total 1 milli, 0.6 milli, 1 minus 0.6 will be 0.4. So IY is nothing but 0.6 milli. We should identify the status of the diode. That was the purpose. So IY equal to 0.6 milliampere implies voltage drop across this 4 kilo ohm resistance will be nothing but plus minus IY multiplied by 4K. IY is 0.6 milliampere. 0.6 into 4 is 2.4 volts. And that was my anode voltage of the diode. Right. And here was my cathode. The voltage drop across 6K is equal to I Z multiplied by 6. I Z is 0.4. 0.4 into 6, again plus minus 2.4 volts. So anode with respect to a reference node is 2.4. Cathode is also 2.4 with respect to a reference node. So this diode now turns on. To turn on the diode, anode to cathode voltage should be positive. This is exactly equal to 0. So you can treat it as an open circuit. The moment it is an open circuit, no current flows through your diode. So your Ix, current flowing through the diode, was equal to 0 amperes. And Iy, as we identified, diode remains in open state, circuit won't change its state, it is in open state only. Iy will be equal to same as your 0.6 milliamperes, not change. I said will be equal to 0.4 milliamperes. It's quite simple. Is it clear? Right.
Hello, sir.
Yes, yes. Correct.
Sir, ഈ കേസിൽ ഡയോഡ് ഐഡിയൽ ആയിരുന്നെങ്കിൽ അത് കണ്ടക്ട് ചെയ്യില്ലേ സെയിം പൊട്ടൻഷ്യൽ ആവുമ്പോൾ ആനോഡിന് കാഥോഡിന് അക്രോസ് ആയിട്ട്?
Yes, രണ്ട് കേസും അത് valid ആണ്. So if you are shorting it, then if you are identifying that Iy and Iz values, you will end up with the same answers. And you will feel that this current is also equal to Iy. This current is also equal to Iz, implies Iz comes, Iz leaves, this branch current will be 0 amperes. That analysis you can do as your homework.
Okay, sir.
Okay? Right. Let us get into the other circuit in which the diode is connected differently. Let us see that. Right, that also quite simple. You can directly answer that question without doing anything. That was quite simple. Right, let us do that. I have two diodes. Equal resistors, 10K here. This is my out. Another 10K in series with the diode connected like this. Negative, positive. This is at 15 volts. Here I am exciting with a 10 volts. This is negative, positive. You are asked to find out the value of V out. V out is the voltage across 10K resistance. Without doing anything, you can directly answer that question. Both diodes are ideal. T1 and T2. And you can identify the status of the diodes. What is the status of D1 and D2? Of course, the circuit will have, theoretically will have 4 possible states. Among that, only one state will be stable state. You can see that input positive voltage maximum value present in the circuit is only 10 volts. And I have reverse biased my D2 with a minus 15 volts. So of course, this will never turn on. And of course, D1 cannot stay in open state because its anode is at positive when it is open, and cathode is branch is open. When D1 is in open state, if you're assuming it as an open state, not drop across 10K, 10K will have a 0 here, 0 volts. And diode was connected like this. 10 volts, A0, forward bias diode. So D1 on, D2 off state is the stable state of the circuit, and this branch remains in open. So 10 volts divides equally between 10K. So we out is nothing but positive 5 volts. No issues. You need not draw all the possible combinations on, then you will identify this is not a valid state. Then you will go for another one, open. This is open, D1 is open, D2 is closed. You will see that that state is also not a valid state. Then you will go for both are open, then that will be also not a valid state. Then we'll go for another state. This is on, this is off. Then that state you will feel that it is a valid state. It matching with the secured node voltages. So directly V out can be written as plus 5 volts. That's quite simple. Right? Any doubts? Copy ചെയ്യാൻ സമയം വേണോ? സ്പീഡ് ആവുന്നുണ്ടോ? എന്തെങ്കിലും ഇഷ്യൂസ് ഉണ്ടോ? Right, 5 volt. എല്ലാവരും ആൻസർ പറഞ്ഞു മിക്കവാറും പേര് പറഞ്ഞു റൈറ്റ് 5 volts. ആൻസർ കിട്ടാത്തവരുണ്ടെങ്കിൽ വീണ്ടും ഞാനത് എക്സ്പ്ലെയിൻ ചെയ്യണമെങ്കിൽ ആവശ്യപ്പെടാം. കുഴപ്പമൊന്നുമില്ല. കാര്യങ്ങൾ പഠിച്ചിട്ട് പോവാം. വീട്ടിൽ നിന്ന് നിങ്ങൾക്ക് പഠിക്കാൻ പറ്റില്ല എന്ന് എനിക്കറിയാം. ക്ലാസ്സിൽ തന്നെ കാര്യങ്ങൾ പഠിച്ചിട്ട് പോവാം. അതുകൊണ്ടാണ് നമ്മൾ ഡീറ്റെയിൽ ആയിട്ട് കാര്യങ്ങൾ പറയുന്നത്. റൈറ്റ്, വീട്ടിൽ നമുക്ക് ഒരുപാട് തിരക്കുകളായിരിക്കും. Right, let us get into the other problem that is based on the rectification property of the diode. We'll see that 6 pi sin omega t is my input signal source. 6 times 5 times sin omega t. I have 2 diodes. Both are ideal. Both are ideal diodes. Both are ideal diodes. Other diode is connected like this towards up. Lower one I have a resistance. And I have a 10K resistance connected in between. These two are, this is 10K and this is 20K. And 2 points A and B are marked. Diode T1 and T2 both are ideal. You are asked to find out the average value of VAB. Average value of VAB. Find the average value of voltage between A node and B node, or this voltage. This is nothing but VA. Don't feel like this is a big one, big circuit. I'm unable to that. Just you analyze your circuit, identify the nature of VAB, then identify its average value. Of course, the input is 6 pi sin omega t. You should visualize it oscillating between 6 pi and minus 6 pi. That everybody knows. Right? And we have two range of input voltages in a broad sense, that is positive and negative. Positive and negative. When Vin is positive, actually we should open both diodes, then we should identify what is the required voltage to turn on the diode, etc., etc. But that is not required here. If you are opening D1 and D2, this branch won't have any connection here, and not drop across this, not drop across this, not drop across this. Here cathode will be 0, anode will be 0. That's the conventional method. And you can see that when Vin is positive, D1 turns on, D2 turns off, because its cathode is 0, anode is positive means it turns on, its anode is 0, cathode positive means it turns off. So if you are concentrating on positive half cycles, directly you can open your diode D2 and short your diode D1. Okay, you need not open it, identify 4 cases, not required. It's clear that Vin 6 pi sin is connected to anode of D1, and if both are in open state, cathode will be at 0 potential. And of course, if Vin is positive, D1 turns on. So here D1 turns on. Is that clear? Any issues? And D2 will be in off state. Then actually this 10K resistance comes in shunt with your voltage source, this 10K. Clear? And there is a current flow in the circuit like this. Okay. So that circuit actually similar to V in 6 pi sin omega t, a 10K in shunt with my source, right? And in parallel with another 10K, this one, right? In series with 20K. And VAB was the voltage drop across 10K. So this is my VAB. Very simple. So this was 6 pi sin omega t. And a resistance connected across a voltage source will not change the node voltage here. So you can remove that. It will change the current supplied by the source, but this node voltage will be same as 6 pi sin omega t, even your 10K is connected or open, doesn't matter. So this is 6 pi sin omega t. So 6 pi sin omega t scales between 10K and 20K. So my signal will be proportional to Vin, and it is only for positive half cycle. So it attenuated by 10 by 3, right? VAB equal to Vin. If this is Vin, VAB equal to Vin multiplied by 10 plus 20, 30. So Vin by 3. And the shape will be sinusoidal itself, no change at all. Right? And its peak value is attenuated from 6 pi to 6 pi multiplied by 10 by 10 plus 20, 30. So 6 pi multiplied by 10K by 30K. So 6 by 2, so 6 by 3, 2 pi. So this value is nothing but 2 pi. Here, pi, it's very simple, 2 pi. VAB is the voltage across 10K. So it's nothing but 2 pi. When your diode is D2 is on and D1 is off, this Vin will appear like this, and your actual circuit was D1 should be open. So this branch, I will open it, and there is a 10K, right, connected to the reference. Here I will have another 10K, and this was my point A, right? This was my point B, and from B to reference I have 20K. Clear? B2 reference I have 20K, and I should short my diode D2. Why? I am concentrating on negative half cycle. Vin is negative, right? So I should short circuit my diode, and I have a connection like this. So it is connected. And the values are 10K. This was 10K, and that was 20K. 10K. I'm interested about this voltage, VAB, right? This is 6 pi sine omega t, and that is less than 0 at present. We are concentrating on negative half, right? So if this is negative, this will be negative and positive. This 20K will appear across your source, as we discussed earlier. 20K is coming across the source, and from that point you will have a 10K, right? This portion 10K, and that is extended to negative supply pole to another 10K. And my VAB should be careful about the polarity here. VAB was negative here, positive. And this was my that 10K. So upper negative, this is positive. So as we discussed, this is 6 pi sine omega t. A resistance across the source can be removed. It will not have any role in fixing this node voltage. That will be 6 pi sine omega t plus or minus, and we are talking about minus. So this is negative and positive. We are talking about negative half cycle. So there exists a positive current in this direction. So this voltage will be always positive only. VAB will be positive even though the input is negative. Because right now we have a negative, positive here. So your input is negative. So if you are taking the current direction, you will have a plus minus VAB. Right? Because this is positive, positive current will flow like this. So this will be, of course, positive. Clear? And the attenuation will be corresponding to how much will be the attenuation? Positive, equal resistors. So 6 pi will be attenuated by 2. So 6 into 10 divided by 20. 6 by 2 will get a 3 pi. Right? So its amplitude will be 3 pi. So in your output waveform, you have first cycle, second cycle, and the amplitude levels are 2 pi and 3 pi, 2 pi and 3 pi, and it repeats, right? It repeats. And the output waveform is, we could identify easily. What about the average value of my output waveform? This waveform is, you need not take it mathematically, integrating will take time. This is actually half rectified waveform plus another half rectified waveform, right? This amplitude is 3 pi, and here it is 2 pi. What is the average value of an half rectified waveform? It is nothing but peak value Vm divided by pi, right? Vm by pi, and Vm is nothing but 2 pi here. So we'll give you 2 pi by pi positive 2. Here it is Vm is 3 pi. So Vm by pi, this is also half rectified. So 3 pi by pi positive 3. So individually, the average values are plus 2 and plus 3. So the average value of this will be at plus 5. Sum of these two average values. So the question was 1, 2, 3, 4, 5 options, 4 options. Last option was 5. Right? അതുകൊണ്ട് മൾട്ടിപ്പിൾ ഡയോഡ് സർക്യൂട്ട് കണ്ടിട്ട് പേടിക്കേണ്ട ആവശ്യമില്ല. നമുക്ക് അറിയാവുന്ന കണ്ടീഷൻസ് അപ്ലൈ ചെയ്യാം, വോൾട്ടേജസും കറണ്ട്സും ഐഡന്റിഫൈ ചെയ്യാം, ആൻഡ് ട്രൈ ടു ആൻസർ ദ ക്വസ്റ്റ്യൻ. റൈറ്റ്? ആവറേജ് വാല്യൂ ഓഫ്, ആൻഡ് സെപ്പറേറ്റ് ക്വസ്റ്റ്യൻ ആയിട്ട് വേണമെങ്കിൽ ചോദിക്കാം, ഈ വേവ് ഫോമിന്റെ ആവറേജ് വാല്യൂ എന്താണെന്ന് ചോദിക്കാം. So you can split into 2 and you can add it separately. So average value will get added. So 3 plus 2 will be 5. And this is a sinusoidal waveform. You can integrate up to 0 to t by 2 pi sin omega t d omega t into 1 by time period, plus this is a shifted sine by 180 degrees. So the function is nothing but sin omega t minus pi, and you should integrate from pi to 2 pi. First signal 0 to pi, second pulse from pi to 2 pi. Then again you will end up with the same answer, but that will be a little bit lengthy. Directly you can write it as plus 5. Right? Any doubts? Any issues? Right. So diode circuit എങ്ങനെ ക്വസ്റ്റ്യൻ വന്നു കഴിഞ്ഞാൽ നിങ്ങൾ സോൾവ് ചെയ്യണം. ഓക്കെ ആണോ? പേടിക്കേണ്ട ആവശ്യമില്ല. എങ്ങനെ ക്വസ്റ്റ്യൻ വന്നാലും സോൾവ് ചെയ്യണം എന്ന് പറയുന്നതിന്റെ കൂടെ തന്നെ ഒരുപാട് ടൈം എടുക്കുകയാണെങ്കിൽ അത് സ്കിപ്പ് ചെയ്യാനുള്ള ഒരു മെന്റൽ സ്റ്റാറ്റസും കൂടെ നമുക്ക് എക്സാമിനേഷൻ ഹാൾ ഉണ്ടാവണം. എല്ലാ ഡയോഡ് പ്രോബ്ലംസും സാറ് ക്ലാസ്സിൽ സാറ് പറഞ്ഞിട്ടുണ്ട് സോൾവ് ചെയ്യണം എന്ന് പറഞ്ഞിട്ട് നമുക്ക് ഒരുപാട് തവണ, ഒരു തവണ ചെയ്തു, 2 തവണ ചെയ്തു, 3 തവണ ചെയ്തു, അത് ചെയ്യേണ്ട ആവശ്യമില്ല. ഇപ്പൊ നമ്മളൊരു ക്വസ്റ്റ്യൻ അറ്റൻഡ് ചെയ്യുമ്പോൾ ചിലപ്പോൾ നമ്മളത് എഴുതിയെടുക്കുന്ന വാല്യൂസ് മാറിയിട്ടുണ്ടാവും. വാല്യൂസ് മാറിയാൽ ഓപ്ഷൻ മീറ്റ് ചെയ്യില്ല, ഓപ്ഷൻ ആയിരിക്കില്ല നമുക്ക് കിട്ടുന്നുണ്ടാവും. നമ്മൾ വീണ്ടും ചെയ്യും, വീണ്ടും ക്വസ്റ്റ്യൻ എഴുതിയെടുക്കില്ല, വീണ്ടും നോട്ട് പാഡിൽ എഴുതിയെടുക്കില്ല, വീണ്ടും നമ്മള് റഫർ ഷീറ്റിൽ റോങ് ആയിട്ട് വാല്യൂസ് ആയിരിക്കും, വീണ്ടും ചെയ്യും, ഓപ്ഷൻ കിട്ടില്ല. ഡയോഡാണ്, സിമ്പിൾ ആണ് സാറ് പറഞ്ഞിട്ടുണ്ട്, വീണ്ടും ചെയ്യും, വീണ്ടും കിട്ടില്ല. അപ്പൊ അങ്ങനെ കിട്ടാതെ വരുമ്പോൾ ഒന്ന് സ്കിപ്പ് ചെയ്യുക, രണ്ടാമതും വീണ്ടും നമ്മൾ ഫ്രഷ് ആയിട്ട് അറ്റൻഡ് ചെയ്യുമ്പം നമ്മൾ കോപ്പി ചെയ്യുന്നത് വീണ്ടും കോപ്പി ചെയ്യുമ്പോൾ കറക്റ്റ് ആയിട്ട് കോപ്പി ചെയ്യും, നമുക്ക് ആൻസറിൽ എത്താം. അപ്പൊ ഒരുപാട് സമയം സ്പെൻഡ് ചെയ്യേണ്ട ആവശ്യമില്ല, ബട്ട് സ്കിപ്പ് ചെയ്ത് പോകാൻ പാടില്ല. സർക്യൂട്ട് കണ്ട് നമ്മൾ പേടിച്ചിട്ട് സ്കിപ്പ് ചെയ്യേണ്ട ആവശ്യമില്ല. Okay, no? Right. So let us get into the other circuit in which 2 diodes are involved. Right? You have 2 diodes, D1 and D2, connected like this. reference. This is my V in. I will mark the diode as T1 and T2. This is 25 volts. This is 100K. This is 200K. This is 100 volts. This is my V in. This is my V out. Question is identify the range of V in which range of V range of input voltage during which both diodes D1, D2 conducts, or both D1 and D2 turns on. Identify the range of input voltage V in such that both diode turns on. Of course, you'll have 4 different options. Right. This is also quite simple, even though 2 resistors, 2 diodes, and 2 sources are involved. You can directly observe that D2 will be on initially. Anyway, let us go for a conventional method. I am opening my D2 as well as D1, D2 and D1. D1 was connected like this, D2 was connected the other way like this. Right? So this potential will be nothing but there won't be a current flow through 100K resistance, so not drop. So we'll get a 25 volts here. Is that right? Opening both diodes, no current flows through 100K resistance because no branch currents. So no drop across 100K, 0 volts. So 25 minus 0 will be 25 itself. So cathode of D1 is at 25 and cathode of D2 is also at 25. So to turn on the diode D1, its anode voltage V in should be greater than 25. That is clear. Whereas your diode D2 cannot be in open state because there is no drop across 200 kilo ohm resistance. So 100 volt will appear here. Its anode is at 100 volts D2 and cathode is at 25 volts. V anode is greater than V cathode. So prior to the appearance of input signal, input can be either, can vary either from minus infinity to plus infinity, doesn't matter. But the entire range, you should identify the range of that V in which both diodes turns on and both diodes turns on. So anyway, let us short circuit my diode D2. Why I am short circuiting my diode D2? Because it cannot be kept as open. Anode is appearing as 100 volts, cathode is only 25 volts. And D1, to replace D1 with a short circuit, we should identify some particular value of V in when both are in off state. And that we observe that V in should be greater than 25 when both are in off. I am emphasizing on that because When this is short circuited, this node voltage will not be equal to 25. That we'll see that. That node voltage is same as your V out. Then V in should cross that particular V out to turn on D1. That we'll see. Anyway, my V out is nothing but some voltage during which D2 turns on. Right. So I will write the characteristics in the other slide. And let me identify the value of V out here. You have two sources shorted, another 200, another source positive, negative, 100, 100, 200, 100, 25. And this is my V out. And my diode, the other diode was appearing like this. And what about this voltage? V out? V out can be easily identified without doing any analysis. There will be a current. That current value will be equal to 100 minus 25 because they are in series, divided by 300. So that is a current I. So I flowing like this, plus minus voltage will drop across 200, plus minus voltage drop across 100. So V out is either drop across 100 plus 25 or 100 minus drop across 200. So 100 minus drop across 200 is nothing but I multiplied by 200. So 100 minus 25 is 75 divided by 300 was the current multiplied by 200 is my out. So this will cancel each other. 75 by 3 is 25. 25 into 2 is 50. 100 minus 50 is nothing but V out equal to positive 50. Or the other way, 100 multiplied by I plus 25. So V out equal to 25 plus 100 multiplied by I. 100 multiplied by I is nothing but 75 by 300. 300. So this will cancel each other. 25 by 75 by 3 is 25. 25 plus 25 plus 25 is nothing but 50. So 50. Both ways. Output is plus 50. So when D1 is in off state, D1 off state, D2 on state, your output is at 50. And the status will not change if your Vin is negative. If your Vin is negative, never D1 turns on because you have a 25. Or if it is short circuited, right now you have 50. This was 25 because both are open, and we understood that D2 cannot be stay in the open circuit. We shorted it. Now output became plus 50 and the same plus 50 available at the cathode of your diode D1. So your diode D1 never turns on, output remains at plus 50. So to change the status of the output, either D1 should turn on or D2 should turn off. Right? So even when input is negative, D1 off, D2 on, so output is at 50. So even when output is input is negative, Vin is negative, output is at 50 volts. Is that clear? No doubts? Output is at 50. Right? And the circuit will remain in the same state if D1 is in open state, right? If D1 is in open state, never ever D2 will become off because the potential here is nothing but 50. When it is open, you'll have 100 here, it will be in closed state. So to change the output of the circuit, diode D1 should turn on. And you are asked to identify the range of Vin in which both diodes turns on. Let us see that. Right? So from your transfer characteristics, V out is 50 even when V in is at a negative range. And your D1 anode signal is not 25 now, it is now at 50, same as your V out. And it is obvious that when your V in crosses plus 50, D1 turns on. Here, this is at 50, cathode, and D1 is now open circuited. If you're increasing V in towards positive side, the moment that crosses plus 50, that D1 will turn on. Right? So I have a level here in which, at which 3 volts. So here D1 off, D2 on. If V in exceeds 50 volts, this is acting as a short circuit. And D2 is anyway, it is in a short circuit or closed state. When both are closed, short circuit, then V in is same as your V out. V in is same as your V out. So it's a linear curve. Slope is 1. Then here, some of you may have a doubt that diode is connected here, another diode was connected here, right? And 100K 25 here, 100K 25 here, then 200K 100 goes here. Then if this is V in, this is short, how V in appears here, you won't have any doubt that it is shorted. V in equal to V anode is equal to V cathode. So this is shorted. So this point you will have V in input signal. That is clear. And this is also on, shorted. Then how come this V in reaches here? Because the diode is connected the other way. So how V in is traveling and reaching here? Because the diode is connected back side. It's nothing but this potential is V in. As long as that V in is less than 100, this diode D2 remains in on state because the maximum potential at anode is 100. This is a variable V in. As long as it is not exceeding 100 volts, it will remain in on state. Still, you will have a doubt that how come this V in voltage is appearing here? Because this is connected cathode and anode the other way. So that's quite simple. V out is nothing but there will be a current like this because it is on. So 100 minus drop across 200K will be your V out. So 100 minus I times 200 is your V out. What is the value of I? 100 minus, what is the value of I? I is equal to, this is short circuited, this is 100, this is this potential is V in, right? V in, not 25, this is V in. And this voltage will be nothing but V in minus 25. V in minus 25 plus 25 is V in. So current is nothing but 100 minus V in, not 25, V in, divided by the resistance here is only 200, not in series with 100K. So this potential is V in. Potential difference is 100 minus V in, divided by resistance is 200K. Multiplied by 200 will give you V out. And you can see that this will cancel each other. Plus and minus will cancel, negative and it will become positive. So V out will be same as your V in. or the circuit current adjusts itself so that this drop is managed so that V out is always equal to this potential. And there is no problem if your diode is connected backward. The only point is that there won't be a current flow in this direction due to the diode connection, cathode to anode. There can be a current flow like this. And that current is fixed by the circuit to ensure V out is always equal to V in. Right? So we could answer our question easily. This diode will become reverse biased when V in exceeds 100 volts that we identified. So both are on condition D1 on, D2 on, okay, in the range 50 to 100. That is clear. And there is one more change in the circuit. If you are increasing your V in beyond 100 volts, what will happen if you are increasing your V in beyond 100 volts? If you are increasing your V in beyond 100 volts, there won't be a change with respect to the diode D1 because your diode D1 anode voltage you are increasing more and more. So it will remain in on state itself. Its mode of operation will not change. As long as your V in reaches 100 volts, your diode D2 will be also in on state, right? The moment V in reaches 100 or just crosses 100, your D2 will become off. So beyond this, my D2 will become off and D1 no change because I'm increasing my V in anode voltage of P1 no change. The moment D2 is open, your input and output are disconnected. You have 200K here, 100 volt source here, no change, and this is my out. The moment D2 is in off state, no branch current here, no drop here. So V out will be how much? 100 minus 0 volts drop. So V out will be 100 volts. So it will stay at 100 volts forever if you are increasing your in. So three different regions, region 1, D1 off, D2 on, and region 2, both are on, V out equal to V in, slope is 1, and D2 off, D1 on. So the question was identify the range of V in both diodes D1 and D2 conducts, and that is the range between here. Right? Any doubts? D1 off, D2 on during the range minus infinity to how much? 50, right? Minus infinity to 50. D1 off, D2 on this portion of the transfer area. And 50 to 100 as we discussed, both are on. Then 100 to infinity, 100 to positive infinity ideally. D2 off, D1 on. And two diodes, 4 different modes of operations are possible, 4 different states are possible. In that we have 1, 2, 3 different cases. And the last case that is corresponding to both are off. That is not a valid state. D1 off, D2 off is not a valid state. Okay. Which one of the following is not a valid state? D1 off, D2 off. Which one of the following is true if V in is greater than 100 positively? D1, D2 off, D1 on. What is the status of the diodes when V in varies between plus 50 and plus 100? D1 on, D2 on. What is the status of the diodes when V in is between minus infinity to plus 50? D1 off, D2 on. Is that clear? Right. Okay. Okay. Any doubts? വളരെ കുറച്ച് പേര് ക്ലിയർ പറഞ്ഞിട്ടുള്ളൂ 1 2 3 എന്തെങ്കിലും ഇഷ്യൂസ് ഉണ്ടെങ്കിൽ ഡയറക്റ്റ് ആയിട്ട് പറഞ്ഞോളൂ നിങ്ങൾക്ക് കാര്യങ്ങൾ മനസ്സിലാവാത്തത് നിങ്ങളുടെ പ്രശ്നം കൊണ്ടല്ല എന്നുള്ളത് നിങ്ങൾ ആദ്യം മനസ്സിലാക്കുക. അപ്പൊ ഡൗട്ട്സ് ഉണ്ടെങ്കിൽ ചോദിക്കാം. റൈറ്റ്, ക്ലിയർ ആണെന്ന് ഞാൻ വിശ്വസിക്കുന്നു എല്ലാവർക്കും. ഓക്കെ, let us have one more problem similar to the problem what we have discussed here. Right, identify minimum value of V in, identify the minimum value of V in such that both diodes in the circuit turns on, This is quite simple. This is my V in, that's minus, this is my V out. I have two diodes that we mark it as T1 and T2. Find the minimum value of V in such that both diodes turns on. We have four options. First option says it's 100 volts. Second option says it is 125 volts. Third option says it is 137.5 volts. Fourth option says it is 187.5 volts. Both diodes should turn on. Here you should note that both diodes are reverse biased. In the earlier problem, one diode was forward biased due to this positive source. Here both are reverse biased.
So second supply voltage.
Yes, sorry. Second supply voltage, let us take it as 25 volts. 25 volts. So 25 volts. So right, let us open both diodes, D1 and D2. Both are open. The moment both are open, open circuit, this is also open. There is no drop across 200 kilo ohm resistance, so Vout will be at 25 volts, irrespective of my V in. Right, output is at 25 volts. So even though my input is negative, because both diodes anode is connected to the input side like this, even though my input is negative, they will be in off state. So even though my input is negative, Vin is negative, I'll have a 25 volts. 25 volts at the output side, and that 25 volts is actually reverse biases the diode D2. It's clear here. And this branch is open this branch is also open, implies there is no drop across 100 kilo ohm resistance. That implies anode potential of V diode D2 will be, anode potential of diode D2 will be nothing but V in. And of course, using our own common sense, D2 diode has a reverse bias of 25 volts, whereas D1 diode has a reverse bias of 100 volts. So D2 will turns on first. So to turn on either D1 or D2, the voltage Vin should be positive, so that they are reverse biased by 25 and 100 volts. And of course, D2 will turn on first. So to turn on D2, we have to raise our input signal to 25 volts. That is clear. Right? So Vin crosses 25 because Vin is appearing at the anode. Cathode is at 25 volts. So Vin crosses 25, D2 turns on. Right? So I can replace with a short circuit. Now Vin is connected to the output side through this network. As we discussed earlier, V out is nothing but, now at present current is flowing in this direction, right? So drop will be plus minus. So V out is nothing but 25, this voltage source, plus I multiplied by 200k, or V in minus drop across 100k. Both are same. And the current is nothing but D5 plus, the value of current is nothing but V in is greater than this 25. So in this direction, V in minus 25, right? So simple. 25 divided by the resistance appearing in between is 200 and 100. So 300 K multiplied by 200. That is quite easy. And this K will get cancelled. So V out is nothing but 2 times minus 25 is minus 15. So V in multiplied by 2 divided by 3. So I will write it as 2 by third of V in, correct? 2 by third of V in. 2 by third of V in minus 2 by third of 25. Right? 2 by third of 25 with the negative sign plus another 25. So V out is nothing but 2 by third V in plus 25, 1 minus 2 by third. So that will give you 2 by third of V in. 3 minus 2 is 1, 1 by 3 is 25 by 3, right? Plus 25 by 3. That is your V out. So the moment D2 turns on, output is linearly depending on V in. Y intercept is nothing but 25 by 3 positive, and slope is nothing but 2 by third, 0.66, so less than 0.5. So 2 by third, right? And that continues. We are increasing V in further, that continues. There is one more diode in the circuit, that is D1 here, connected like this, anode on top to cathode like this, 200 volt source. And my V out is nothing but, right now it is 2 by third of V in plus 25 upon 3. The moment that voltage or anode voltage is same as your output voltage, if that anode voltage or output voltage of the circuit 2 by 3rd V in plus 25 by 3 equals how much? 100 is the reverse biasing. So anode voltage reaches 100 volts. D1 turns on. So that will give you 2V in plus 25 is equal to 300. V in is equal to 275 divided by 2. That will give you V in is equal to 75 by 2 is 37 by 5. So 137.5 volts. So once D2 turns on, that never turns off because anode of D2 is V in. We are increasing that, never turns off. But as your V in or V out or anode of diode D1, anode voltage of diode D1 reaches 2 by 3rd V in plus 25 by 3 reaches 100 volts, that forward biases the diode T1, right? Acting as a short circuit. Once it is acting as a short circuit, without any doubt, D2 will be in on state itself because its reverse bias is only 25. Here we are having 100 now. Then V out is nothing but 100. Constant 100. Because this source is shunted with the output 100 volts. And voltage across 200K will be now 75 volts in this polarity. So that the entire output is at 100 volts. 25 plus 25 is 100 volts. So our question was identify the minimum value of V in such that both diodes turn on and both diodes turns on in this range. The minimum value here is nothing but equating to 100 anode voltage. And that voltage we got it as 137.5, and third option was the right answer. Right? So multiple circuits with multiple resistors and voltage sources are also quite simple compared to single diode circuit. And you should apply your fundamental network theory and basic understanding of Clipper circuit along with understanding of your ideal diode response so that you can identify the respective V in or V out values. Here also the circuit will have two breakpoints, 25 and 137.5. If input is beyond 137.5, if you are going up to infinity, no change, output remains at plus 100 volts because D1, D2 remains in on, D1 also remains in on state because input is appearing at the anode side of both diodes. Both diodes will conduct. Right? Any doubts? Any issues? Last problem. Right, we will wind up today's session after discussing one more problem in which a non-ideal diode exists, right? So we'll have one more case. Given the diode is non-ideal, with a cut-in voltage V gamma equals 0.7 volts. This is Vx upon 2. This is source. 2 volts. Diode is non-ideal with a V gamma equal to 0.7 volts. That implies to turn on the diode, its anode to cathode voltage should be at least 0.7, not equal to 0. 0 was in the case of an ideal diode. Right. Identify the value of identify the minimum value of Vx, such that the current Ix equal to 0 in the circuit. Identify the minimum value of Vx such that the current in the circuit Ix, series current Ix equal to 0. നിങ്ങൾ ആൻസർ പറഞ്ഞാൽ നമുക്ക് വൈൻഡ് അപ്പ് ചെയ്യാം. 500 ohms. Diode is non-ideal with a V gamma of 0.7 volts. This is positive 2 volts here. Answers: identify the minimum value of Vx such that current Ix equal to 0. Right. Answers: right. Right. Okay. Right. 2.6 ഒരുപാട് പേര് ആൻസർ ചെയ്തു. Right. So let us solve it quickly. You are opening the diode. The diode is a non-ideal one with a V gamma equal to 0.7. So implies its anode voltage is at 2 volts when it is in open circuit condition, and this voltage is nothing but Vx upon 2. This is my anode, this was my cathode. So since it is a non-ideal one, V anode minus V cathode should be always greater than or equal to 0.7 volts or V gamma to turn on the diode, and Ix will be 0 when the diode turns off. So if VA minus VK less than or equal to 0.7 volts, the diode turns off. Clear? V anode is nothing but 2 volts minus V cathode is nothing but Vx upon 2. Vx upon 2. If that is less than or equal to 0.7 volts. Right? That implies if Vx is greater than or equal to 2.6 volts, your current will be 0 or the diode will be in off state. You are asked to identify minimum value of Vx, so greater or equal. So minimum value of Vx will be corresponding to Vx is equal to equality condition 2.6 volts. right? So right option is 2.6 volts, right? So നമുക്ക് ഇന്നത്തെ സെഷൻ വൈൻഡ് അപ്പ് ചെയ്യാം. Any doubts? സംശയങ്ങൾ എന്തെങ്കിലും ഉണ്ടോ? KCB ഈ ബാച്ചിന് നാളെ പവർ സിസ്റ്റം കണ്ടിന്യൂഷൻ ആണ്. ലെക്ചർ പോളിയുടെ ക്ലാസ് ഇന്ന് ആഫ്റ്റർനൂൺ അനൗൺസ് ചെയ്യാം എന്താന്നുള്ളത്, റൈറ്റ്? എന്തെങ്കിലും സംശയങ്ങളുണ്ടോ? So let us wind up now. Thank you for listening to the class. Thank you very much. So we are completing Clipper circuits.